Hello friends, very good morning. Myself Professor M.H. Annaya. In this video, I'm going to give you some important tricks to solve projection of cones. Friends, cone has got a circular base and the highest point above the center of the base is called the apex that have represented by O dash. And whenever you place any cone on HP on its base, in the top view you see a circle and in the front view you see a triangle as I have shown here. The diameter and the height of the cone will always be given and you should be able to draw the front and top views. Friends, generally an important tip is that whatever may be the position of the cone in the second tilt, in the first position, it is going to be a triangle in the front view and a circle in the top view. And friends, this portion of the question will fetch you one third of the total marks allocated. And friends, this is the first step. In the second step, friends, the cone may, or you may be asked to draw the projection when the cone is resting on one of the end generators. End generator means last generator. The generator to the right side of the observer and that to the left side of the observer are called end generators. Friends, in this first part, I have got a cone of diameter 50 mm, height 70 mm, resting on HP on its base, and we have drawn the front view and top view of the cone. Friends, since it has no edges or corners around its periphery or on the base, we are going to divide the circle in the top view in case of both cylinder and cone into minimum 8 number of equal parts. So I have written this and have divided this into 8 equal parts and let me name them as A, B, C, D, E, C. This is D, E, F, G and this is H. Friends, this is O dash is the apex and this is the base, and if you transfer these points you get A dash, this is E dash, center is C dash, G dash. Since there is not much space, I will just show only this many number of parts in the front view. Friends, this is the initial position. Even in the case of a cylinder, simply place the cylinder on HP such that it rests on one of its circular ends on HP and get the top view a circle similar to the cone and front view is going to be a rectangle with width is equal to diameter and height is equal to the height of the cylinder. That will be specified in the question. Friends, here this is the first position and if you observe this last line, here this last line O dash A dash is called an end generator. There are 8 such generators. We'll call this as an end generator. End generator. And you find friends, this is inclined to HP. But in the question, you have been asked to draw its projection when the core is resting on an end generator on HP. So friends, I have to redraw this figure 1 as figure number 2 such that this end generator O dash E dash lies on this XY. So friends, I am going to write a triangle here. The same triangle is redrawn here with the same dimension such that this A dash will go to the top and E dash will be here. This is O dash and whatever the generators you have got here, like the generator OA, OB, OC, etc., are to be marked here. And closer to A is B and H. Say this B is here. So B dash, H dash, this is C dash, G dash, and this is D and F. This is at the same distance, D dash comma F dash. This is O1 dash, O dash will join this to the apex. All these points are joined to the apex. Friends, this is how the cone looks when it is resting on one of the end generator. I'll mark here. I'll say this end generator on HP. That is O dash E dash is an end generator that is on HP, and this is our O1 dash. Friends, after you place the object on HP, you have to see from the top and find out how it looks in the top view. This is a front view already, top view. For this, friends, I had given you in one of my previous videos that whenever any cone or pyramid is resting on HP, either on an end generator like a cone, or on slanted in case of a pyramid, or on triangular surface on HP in the case of a pyramid, the complete base of the solid is visible in the top view. And hence, friends, I am going to obtain all these points, 8 points of the base, and let's see how it looks in the top view. So write a vertical line from here, a horizontal from here. This is our point, say E. Similarly, vertical line from here, horizontal line from here. You are going to get this point A. At the top end, G. Horizontal from here, vertical from G. It passes through exactly the center. And here you are going to get the point G. On the other end of G, you get C. This is the point C you get. So you got A, B, C. So B and all you get now. Now friends, we have got the point A, and these four corners you got C and G you have got. Let us draw lines from this D and F. D and F. If you draw vertical line through that and horizontal line through F and D. So friends, this is one point, and for this D, we are going to get another point here. Similarly, at the equal distance on the other end, we are going to get B and H. So friends, this is going to be B, this is B, that is A, B, C, D, E. This point is F, this is G and H. Friends, this was a circular surface, and since it is lying on HP, this appears as an ellipse. So we will join all these 8 points so obtained by a continuous smooth curve. So friends, this is how this base will look in the top view. So friends, this is O1, and you have this apex O. So draw a horizontal line from here, and from this O, draw tangent to this curve through this point O. Friends, you are going to get this OG. Similarly, you are going to get this point, and all other points you are going to obtain like OB, OH, etc. Friends, this is how it looks in the top view. And friends, if you have completed the portion up to here, I told you there will be 3 stages in the projection of solid. The first stage comes to you, you will fetch you 5 marks. This you will get 5 marks, totally 10 out of, or 10 or 12 out of 20 marks. 2/3 of the marks you get. Friends, what else they can ask in the next view is that, friends, they may ask you to draw its projection when the axis is parallel. If it is axis parallel to VP, you have to stop at this stage only. Now it is axis parallel to VP. You have to stop at this. It is resting on the end generator and the axis is parallel to VP. Or the continuation, if they say axis appears to be inclined at 40 degrees to VP, if you have the word appears to be inclined, redraw this figure as figure number 3, such that whatever the angle the axis makes with the VP to be drawn here, and this figure has to be reproduced here at that given inclination, and we obtain the final front view. And again, in the same question, if they say that the axis or top view of the axis inclined to B, so O1 is the top view of the axis, you have to reproduce this again here on the line, inclined at an angle of the given value and obtain the front view. So for all the solids, whenever you decide that axis appears to be inclined to VP or top view of the axis inclined to VP. In these two cases, whether you have a prism, a cylinder, a pyramid, or a cone, whatever it may be, you have to redraw the second top view as it is at the given inclination. But if you are given a question wherein the top view of the axis is inclined to VP, friends, if you observe this figure, the original axis length was so much 70, even this is 70, but here because of the inclination, this O1 is lesser than this O dash O1 dash. In such case, whenever there is reduction in the length of the axis in the top view, then you have to take locus and obtain this top view by taking locus of that apex and obtain the front view. So this is an important part and is applicable to all solids, friends. Now, friends, we have dealt with the cone resting on n generator. Remember, friends, you have a question on solid on a cone. Simply draw this front view and top view. You can pocket easily 1/3 the total marks allocated. Next, if they say it has to rest on n generator, know what n generator is. This is n generator. Make it to rest on HP like that. You get another 1/3 of the total marks allocated in the second view. And the third position depends on whether the axis is inclined to VP, top view of the axis inclined to VP, or axis appears to be inclined to VP. So based on that, we are going to complete the third position and obtain the remaining 1/3 of the marks from that view. Friends, after knowing, see friends, this is one of the very important questions they ask you on code, resting on n generator on HP. Now friends, what we will do, we will have the second case which is also equally important when the cone is resting on, what other position possible? So the cone is resting on a point on its base periphery, on the circle, base periphery. Friends, the cone is resting on a point of its base periphery. So friends, it was like this, initial position I am retaining, then when you just rotate or tilt like this, it will rest on corner E or a point on the base circumference, that is A, B, C, D, E, anywhere it could be. So if we tilt to the right side, it will rest on corner, not a corner, a point of the base circumference, such that the axis will make some angle. So let us say that axis at 40 degrees to HP, say, because when you tilt this, you have to have the angle made by that. So friends, I am going to have the figure redrawn. So the same figure redrawn, friends, here. This is our point A dash, this is E dash, this becomes the axis of the solid, O dash is the apex, this is C dash, G dash, next to A you have B and H, B dash, H dash, this is D dash and F dash, D dash, F dash, all to be joined to the apex like this, friends. Now you can see here, friend, this in the second step you have to be extremely careful. Suppose say in the question the axis is inclined at 40 degrees to HP, and you know very well the inclination to axis of the axis to HP can be seen in the front. This is what they are given. 40 degrees to HP. Or the same position may be retold as that the base of the solid, that is that line, this complete line is the base, is at an angle of 50 degrees to HP. Means the same. Whether so, just to confuse you, they will give you inclination of the axis O dash O1 dash with HP, or the base of the solid with HP. If you add these two together, you get 90. 50 plus 40 is 90. And this is 90 here because the base and the axis are at right angles to each other. So friends, in this what happens friends? When you look from the top, friends, you will have the top half portion of the base is visible and the remaining half is covered. So you will be able to see the portion from A to C, CG, and the portion below that not visible. So let's see friends how to get them. So let me mark the extreme points like A and E. A vertical line through A, horizontal line through this. This is our point A. Similarly, vertical line through B, horizontal line through this. This is E, sorry, E. This is E I have to mark. So this point is E, and here you get exactly in the center C and G. So horizontal through G will give you this point as G, and similarly here to the point C, if you draw, you are going to get one more point here. So this is A, B, this is C, D, and all you get friends. On the same lines, friends, if you want other points, project one by one. So B and H should fall on this line, B and H. So through H, I will draw a line. This is our point H. On the other end to H, you will have B here. At the same distance, B you will have B, and opposite to B, you will have D here. So you will have the D here, and opposite to this you will have the point F. A, B, C, D, E, and this point is F. And finally you have this apex O, vertical from O, horizontal from the center of this, that is O1, will give you the apex O. Friends, if you observe here, this portion from C till that G, the top portion is visible to the observer. So join all that portion by a continuous smooth curve. And similarly, the remaining portion has to be shown by a dotted line because the bottom half portion of the solid is not, this portion is not visible, whereas the upper portion is visible. After getting this, draw a tangent through O to the ellipse, and again another one here, a tangent. Friends, this will represent the top view of the solid, and this is the front view of the solid, and this half the portion is not visible, and now the axis of the solid is parallel to VP but is inclined at an angle of 40 degrees to HP. Friends, the final question will be in that they will ask you draw its projection when the axis is inclined at 40 degrees to VP, say 30 degrees to VP. Axis inclined. Friends, you find axis was of length 70 and this was 70. Now it is reduced because of the inclination. So whenever there is reduction in the length of the axis of the solid, then you will have to take the locus. So you have to redraw this figure by taking the locus of this O or this O1, obtain the final top view and front view. Friend, that will fetch you another 130 mark. Friends, these two questions are very important in case of cones. That is, cone resting on end generator on HP is one important question. The second question is the cone resting on a point of its base circumference with the axis inclined to HP. These are very, very important questions that are generally asked on cylinders. Friends, there is one more question which is also equally important and sometimes asked in the examination. That part also I will complete. So it is a cone resting on a point of its base circumference, of its base circumference or base periphery circumference, base circumference, such that the generator generator through that point rests on VP. That is to say, one of the end generator is on VP. Friends, this is the end generator you have got here. And friends, to make this end generator to touch VP, are written here, to touch VP, what is to be done, friends? I am going to redraw this figure as it is with that particular end generator O dash E dash perpendicular to HP. This makes an angle of 90 degree. I mark all other points of the base like A dash, this is C dash, G dash. Say only 4 points I will show here. And this is, friends, O1 dash. Now he has specified less than a point of its base circumference on HP. Circumference on HP you have to say. On HP. Such that the generator through that point, generator is now here. Let us see how it appears in the top view, friends. Through A and E, and this is through C and G. Friends, you are going to get one point here, second point here, third, and this is the fourth point. This point is, friends, A, this is C, this is G, and this is E. In between you will have 4 more points, and you will get them by projecting these lines. So you will get 2 points here. So you can show those points also here, friends. So these are the 2 points, and equal distance on the other end also you will get 2 more points. You have so many points. Friends, you will be able to see the complete base of the solid here, friends. So I am going to join all these points by a continuous smooth curve. This is how it looks, friends. Your O dash is here. This is O comma E. O comma E is this point. And if you are joining all these corners to that, friends, you will have a figure like this. So this is how the cone looks in the top view when one of the end generator is is perpendicular to HP. I'll write on here, end generator perpendicular to HP. Friends, now the point OE or the line OE is away from VP. It has to be on VP. That means to say, friends, I have to reproduce this figure such that this OE touches XY line, and this A and the point E, A will be away from that. So friends, what is to be done for that is, friends, I am going to enclose this ellipse in a box. We'll call that box as PQRS. Say this is P, Q, R and S. So for all these distorted figures like an ellipse, a semi-ellipse, a pentagon, a hexagon. So apart from this square and rectangle, all other figures in the top view or in the front view are to be enclosed in a rectangular box, and that box is to be reproduced in the next position. So friends, I want to keep this OE here. So I will draw this PQ line. Whatever the length you have got here, I will mark that PQ here. So one side is P, the other side is Q, PQ, and this is PS. So we are going to have this box constructed here, friends. So this is vertical will have more dimension, CG will have more dimension, and OA will have lesser dimension. So this will be of lesser length. And remember, friends, this is going to be 50, it won't change. This will be 50, but this length will be less than 50. This is P, Q, R, and S. Friends, we have to locate all these points. Exactly in the center of P, Q, we have OE. So I will locate that point. I will call this point as O, comma, E. Then friends, opposite to this OE is point A. This point is A. I will mark it as A here. Then friends, we need to have G and C. G is on PS midpoint. This is C. Midpoint of this PS is G. And the other opposite side you have got C. So only 4 points I will show. The other points also can be shown and the same way, friends. So friends, we are going to have the figure reproduced. Same figure. This figure and this figure are exactly identical. Friends, now I have to get the points one by one here. Friends, first of all, let us mark O. So O is here, friends. This point is O dash. And friends, here A and E you will get here. A. So friends, vertical through A. This is A. Vertical through A and horizontal through this point is going to be the point A dash. Then here you are going to get E dash. This E dash will be here. So A dash, E dash. Then you are going to get in the center of this C and G. So we'll draw a horizontal line through this and say this is C and G. Point through this is G and point through C is this point C dash. This point is G dash. Likewise, friends, you will get all other points here. I have shown only 4 of them. And friends, since this is touching, this end generator is touching the wall, you will be able to see the complete base. That's going to be an ellipse again. Complete ellipse of the solid is seen in the front view. And friends, from here, draw tangents to this, tangents, and this is the midpoint of that is O1 dash. Friends, this is how the front view of the solid look. And I have not shown this generator like other 4 generators. Here, friends, O is to be joined to all these. So O to G, O to A, O to C, all that I have joined. And friends, you can observe here the end generator OE or O dash E dash is on the wall. Since it is on the wall or VP, you will see it as a point in the top view because that is seen as OE. O dash E dash is perpendicular to HP and so hence it is seen as a point on OE. So this is the front view and this is the corresponding top view of the solid. And friends, this is how we obtain the projections of the solid. Friends, I will just give the final summary of this. Generally, for all problems on cone, the 2 very important questions on cones, that is projection of cones, are the cone resting on end generator on HP is most important. The second important question is the cone resting on a point of its base circumference with the axis inclined to HP. Second important. And third one is the projections of the cone when it is touching the vertical plane VP like this by one of the end generator. This O is the end generator. So these are the 3 important questions that are generally asked on the chapter projection of cones. Friends, I hope the presentation was interesting and please go through the complete video. If you like this video, give a liking to it and share the information about my video and my YouTube channel with all your friends without fail. Thank you for watching my YouTube video. Have a blessed day.